Welcome to another Mastercam lathe lesson. You can see here I have my geometry created. The stock has been set along with the chuck jaws. We have a facing operation that faces to Z0. I can tell easily because I've provided that information in the comment. I've got a roughing profile and I've got a finishing profile. So all that remains for this workpiece is a grooving operation and a threading operation, but all that we're going to discuss in this video is the grooving operation. So let's get started by selecting grooving. And before we begin selecting any chains, we have an option about how we do that. So for the time being, I'm going to recommend going with multiple chains. So what this allows us to do is select both of these chains as part of the same operation, or both of these grooves as part of the same operation. But it provides an efficient tool path between the two. So it will rough them together, and then we'll go back to the first one, finish this one, and then finish that one, all part of the same operation. So I'll click check mark, and then what brings us to our familiar chaining window. And the way we chain a groove is to pick the most extreme wall to the right hand side that's going to be cut as part of this operation. And since we're removing this section of material right here, the gray line indicating the rough stock that's left over after the finishing operation, in order to remove this material right here, we have to select that bit of geometry. So this is going to be the most extreme wall to the right. This will be the most extreme wall to the left. And just as usual, we want to be selecting what I refer to as the first half of the line that you're going to be cutting first. So we don't want to pick down here on this line. It's going to be down here, the first half that the tool engages with. So we pick the right line, pick the left line. That completes one chain. We have our green arrow indicating the start, red arrow indicating the end, and then the direction of the arrows indicating kind of the direction of which the groove will be formed. And then we're going to go over to this groove right here, select that as well, green check mark, and then it brings us into this familiar window. So as usual, I'm going to advise that you select a tool from the available menu that most accurately reflects the tool that you have available in your shop. So this tool right here pretty closely resembles the tool available in the shop that I'm working at. Let's select that one and make sure that tool 6 is correct. Offset 6, station number 6. Sometimes you get some incongruity between the information right here and the information over here. This is the stuff that counts when you post your program, so do be careful and make sure that you have your proper tool number, offset number, and station number over here. If we go with a feed rate of about 0.0035 inches per revolution, that's been working well with the tool that I have in the material that I'm cutting, and coincidentally 200 cutting speed has been working well as well, so I'll leave that alone and I'll change the finish cutting speed to 200 as well. If you do forget that, it's not the end of the world, but this will help you get a better surface finish if you control cutting speed. And then we're going to set a max spindle speed for safety, 2000 RPM. Make sure the coolant is turned on. I'll use force tool change even though I don't need it in this particular case, just a good habit to follow. And then let's call this grooving, make that comment, shout it out. And notice that there is a pretty detailed list of menus here that I'm not going to get into just yet. I'm just going to hit check mark after setting the tool cut parameters and see what happens. Okay, so we have some good looking tool paths. We don't have a tool crash. Everything's looking pretty good. All the material has been removed. You can see the gray and white lines are overlapping, meaning that your rough geometry is aligned with your finished geometry. But we have a couple of problems here. This isn't ready just yet. So one concern that we have is the width of the insert that's going to be cutting this groove. We need to make sure that in this tool information it matches what we actually have in our shop. And you can access this two ways. One is through the parameter window. You can right click on the tool and say edit tool, or you can select the tool information right from this menu right here. You can see it's available for all of your other tools: roughing, finishing, grooving. So I'm just going to select right there. And then this information is what we need to concern ourselves with. These is the bits of geometry that describe the insert that we're using. So A being the insert width at the point where it's inside the body, E is the overall length, D is your cutting width, and this is the one that we're worried about right here. And if you're in doubt about whether it's D or A being the cutting width, D is wider than A, which means that it provides clearance for the rest of the tool as it enters the workpiece. So D, the widest point of the insert, is your cutting width, and right here it says we have a width of 0.125. Now the shop I'm working at has 4 millimeter or 0.1575 if converted to imperial, and that will impact the operation. So it says here, changing this tool will update your operations. Continue, and yes, we want to continue. So if you have a 1/2 inch wide groove, it takes more cuts for a narrower insert to create that same size of groove. But with a larger insert, you can cut the same groove with fewer passes. So let's take a look in Backplot to see what that looks like. That looks pretty good. Again, no crash. We are accurately reflecting the width of the insert. If we go back into the parameters, we can see right here 0.1575 has been updated from 0.125. So then you might be asking, well, what other things might we need to control in these parameter windows if this appeared to be pretty good at a glance in the work menu? And to be honest with you, you can get away with changing very little as far as the groove goes. So in order to achieve an appropriate groove width, that must be controlled by the width of the insert right here. If you have this width incorrect, you'll never get your groove width correct on your program. You'll have a lot of difficulty at the very least to try to accomplish that. So in order to achieve size dimensions or width dimensions, that's achieved right here, and there's no computer compensation or anything to adjust for that. The only thing you might want to adjust when you're machining your workpiece is the diameter or the geometry of something like a V-groove where your feed is a blend between X and Z simultaneously, in which case you can go back to your parameters, go to the finish parameters, make sure wear is turned on, and otherwise the default settings for grooving operations in Mastercam typically work very well on their default settings. If you want to leave a little bit more or less material to leave in X and Z for finishing, you can do that right here. But generally speaking, when I'm doing grooving in Mastercam, I leave the vast majority of default settings alone. So I encourage you to experiment with things like leading in and leading out, different groove shape parameters. You can pick the angle with which the tool maneuvers through the workpiece. Maybe that will change depending on if you have maybe a round groove or a larger V groove. There are many reasons why you can change the parameters for your groove in Mastercam, but as usual, I recommend changing only one parameter at a time. Observe the difference, see what it gets you, and you can do a lot of experimenting before you actually run your program on the machine, paying close attention to the changes that you're making in the parameter window. And if you have any questions, leave them in the comments below, and I'd be happy to address them individually. Thank you.